What is up, everybody? All right, we're on to Unit 8.2, and this is kind of a review of Pythagorean theorem. And then we're going to talk a little bit about how can you tell if a triangle is acute, obtuse, or right if you are only given the side lengths. So like no diagram, no picture, just side lengths. All right, so the beginning part of this is going to be very much review. So remember, with the Pythagorean theorem, A and B are the legs. And it doesn't matter which one you label A, which one you label B, because we're going to be adding their squares up. And then our C is always our hypotenuse. Okay, so that means in this diagram, this would be A, this would be B, and then this long side would be C. And hopefully we all remember that our Pythagorean theorem is A squared plus B squared equals C squared. Right? And in the past, right, we've talked about, okay, when we solve this, can we use a calculator to get the decimal amount, or maybe we had to do a simplified radical. So please be aware that you might be asked to do one or the other or both. Right? So if I'm looking at these two diagrams, the biggest area of mistake that I always see people make is they'll put whatever they're solving for as the C. But remember, the C is always the hypotenuse. So the side length that we're trying to solve for can change. However, the C is always the hypotenuse of the triangle, the side opposite the right angle, the longest side. So for each of these problems, our X is going to be in a different location. So if I'm looking at this one on the left, 17 and 7 are the legs, X is the hypotenuse, so it'd be 7 squared plus 17 squared equals X squared. Compared to the one on the right, X is a leg, so I would do X squared plus 22 squared equals 25 squared. Right? And so from there, you would just use your calculator to kind of figure out what those are. So 7 squared is 49, 17 squared is 289 equals X squared. 49 plus 289 is 338, and then the square root of 338 is 18.4. Okay. Now again, we might have to do like simplifying radical. So if I was going to simplify this radical, off the top of my head, I can't think of any that go into it, so I'm just going to start dividing by like 64, 81. I don't think 338 is going to be able to simplify at all. So like if I was asking you what is the simplified radical, you would just leave it as the square root of 338 because no perfect squares go into that value. Okay. The one on the right, 22 squared is 484, so X squared plus 484 equals 25 squared is 625. So 625 minus 484 is 141. I can tell you that there are no perfect squares that go into 141. So it would be X equals square root of 141, or as a decimal, that would be 11.9. Okay. Now let's take a look at a little word problem. Okay, so to be safe, a ladder's base should be at least a fourth its length from the wall it is leaning against. So if a ladder is 20 feet long, how high can it reach? Now, big thing to know, right? Let's say we've got our wall, and you've got your ladder right here. The further away I move the base of the ladder, obviously the lower on the wall I will reach. Okay, so if our ladder only has to be a fourth of the distance away, the closer we are to the wall, the higher our ladder will reach, right? So if I want to make my diagram here, I would say wall. This part's my ladder right here. So I know my ladder is going to be 20 feet. That's not going to change, right? Like no matter how I position the ladder, it's always going to be 20 feet. But where I position it as far as the distance from the wall is going to change. Now, it has to be 1/4 its length. So 1/4 of 20 would just be 20 divided by 4, so that's 5. So the furthest away or the closest we can be to the wall while still going by the safety protocol is 5 feet, right? And so we're trying to find how high up that ladder will reach on this wall. So here's our setup now. Our hypotenuse is 20. Notice that the ground and the wall make a right angle, and then the ladder makes the hypotenuse of our right triangle. So because 20 is our hypotenuse, it would be x squared plus 5 squared equals 20 squared. X squared plus 25 equals 20 squared, which is 400. Subtract the 25 from both sides, so x squared equals 375. Square root of 375 is, as a decimal, 19.4. 375 divided by 25 is 15. So if I wanted to simplify this, it would go rad 25, rad 15. The rad 25 becomes a 5. So as a simplified radical, our answer is 5 rad 15. Okay. Pythagorean theorem, we should have no issues whatsoever. Okay. Please reach out if you do. And again, just practice decimal ones, or using your calculator to get the decimal result, and also a simplified radical when you have a factor tree. Now the new part of the lesson is this right here. So how to determine if a triangle is right, acute, or obtuse. Okay, so we would use this concept if we're given 3 lengths and we're asked to determine what type of triangle it is without a diagram. Now with a diagram, usually we can tell, okay, it's acute. Remember, that would be all angles are less than 90. Obtuse, one angle is greater than 90, or right, where it has one right angle. So here's kind of the setup, and I'll kind of walk you through it. But here's the key thing to remember. C is still always going to be our longest side. So no matter what type of triangle we have, the C in this setup is always going to be the longest of the 3 sides you are given. So if the shortest side squared plus the medium side squared equals the longest side squared, we know that that becomes a right triangle. Okay? If the shortest side squared plus the medium side squared is less than c squared, or less than your longest side squared, that is an obtuse triangle. Okay, and you guys, you'll see how this works once we do a couple examples. And then finally, if a squared plus b squared is greater than c squared, so if our shortest side squared plus our medium side squared is greater than our longest side squared, that is going to be an acute triangle. And again, we determine which one of the sides is our c, because the c is always the longest side. Okay. So here we have 7, 14, and 16. So 16 is our longest side. So that means 16 equals c. It doesn't matter if 7 and 14 are a and b, because you're adding the squares together. So 7 squared plus 14 squared. And what we're going to do is we're just going to hypothetically say it's equal to 16 squared. It might not be. It might be less than, it might be greater than, or it might be equal. So we know 7 squared is 49, 14 squared is 196, and then 16 squared is 256. 49 plus 196 is 245. So a squared plus b squared is less than c squared. So if I go back to my chart on the left-hand side, a squared plus b squared is less than c squared, so this is an obtuse triangle. Okay. Let's do another one. Longest side, so that's my c, so 41 equals c. 9 squared plus 40 squared equals 41 squared. Again, that's a hypothetical equals, it might not. So 9 squared is 81, 40 squared is 1,600, 41 squared is 1,681. 81 plus 1,600 is 1,681. So notice these are now equal. So if those values are equal, we have a right triangle. Okay, and then obviously, guys, if you had a squared plus b squared is greater than c squared in this equation, then that would make it an acute triangle. Okay? I'm actually going to stop the video right there, even though I have this right here. The big thing to note, guys, is whenever you have an isosceles triangle with the altitude drawn in, remember that's going to bisect this right here. So that means that to solve for that altitude, I would have a triangle that would be 10, and this would be 4, because the altitude's bisecting the base in any isosceles triangle. And then for the one on the right, we could just make a little rectangle right here. I know this would be 5, I know this would be 7, I know this is a right angle because that's a right angle, and then I can just use Pythagorean theorem to solve for the hypotenuse. Okay? Let me know if you have any questions. It should be pretty straightforward.